These are the examples for Algebra 1A, Credit 3, Lesson 7.1. In Lesson 7.1, we're going to be talking about modeling a situation with an expression, and then also expressing that as a graph, and then even answering a question about the graph in order to resolve a situation or to answer a problem. Okay, so let's take a look at number one, and this will be our example for number one. So it says, given the real world situation, write an equation to represent the situation. So number one says a frozen yogurt company charges customers a flat fee of $1 plus 30 cents per ounce. Let X be equal to the number of ounces of yogurt. So wish things were still that cheap. So for our example, we're going to we'll do something a little bit different. We're going to do a pizza, and the pizza is going to have a flat fee of $10. The flat fee, or just basic pizza, I guess. I don't think we talk about pizza as fees, but the basic pizza, let's say a cheese pizza, is $10, and then each additional toppings are $1.25 each. So toppings $1.25 each. All right, so first of all, we want to write an expression that would model this situation. And so let's go ahead and do that. So the pizza, the $10, whenever we hear the words flat fee or basic charge for a cheese pizza, that's not going to change. That's not a variable, or that's not going to vary. And so no variable with the pizza. However, the toppings, remember those keywords we've talked about, each or per or every, that is a keyword that tells us where the variable goes, because the toppings aren't just $1.25. Well, they are if you get just one topping, but they're $1.25 for each topping. So if we're going to let X represent the number of toppings, the charge per topping is, or the charge for the toppings is $1.25 times X. Remember, X is going to represent the number of toppings. Let's go ahead and write that up there. X is the number of toppings. All right, so that is that's all we have to do for number one, write our expression, but being careful that we put the variable in the right place. So when something is like a one-time fee, we're not going to be multiplying that by any variable, because again, it's a one-time fee. It's our fee for the cheese pizza. That's $10. And then the toppings, we could get one topping. We can get 5 toppings, maybe like a combo pizza. We have any number of toppings. We can have 0 toppings if you just want a cheese pizza. So it's $1.25 times the number of toppings. All right, so that's our example for number one. So now number two is going to ask you to use the equation or expression, I guess this would be, that we wrote in problem one to determine the cost of buying frozen yogurt. So again, we're dealing with pizza here as our example. So for number two, for example number two, and by the way, I didn't finish reading that, buying a frozen yogurt with weighing 4 ounces. So, all right, so in our example, we're going to have actually, we said 5, so let's use that. We're going to have 5 toppings in our pizza. So I guess we want the combo. We want several toppings here. So what we're going to do now is take that number and substitute it in for X, and then we'll simplify that expression. So we have 10 plus 125X, and we're going to substitute 5 in for X. Now, you might be tempted to work this out by adding first, but remember the order of operations that tells us that we're going to multiply first, then do our addition. Remember PEMDAS, please excuse my dear Aunt Sally, or however you may have learned that. So multiplication comes before addition. So we take $1.25 or 1.25, and we're going to first multiply that by 5, and we get 6.25. And now we're going to add that up, 10 plus 6.25, and we get $16.25 or $16.25 for our pizza. So even though a basic cheese pizza just costs $10. In fact, maybe that's what we should call that. So pizza's $10 for a cheese pizza instead of a flat fee, right? And so even though the cheese pizza is only $10, when we add 5 toppings on that, that adds an additional $6.25 because each of those toppings is $1.25. So altogether, when we add that up, $16.25. All right, so now let's go over to, and that's all we're going to do with those two, all we have to do. And so now let's go to the next page, page 45. And it says Avid class is having a bake sale, and they are selling cookies and cake to raise money for a field trip. A bag of cookies cost $3, and a slice of cake, well, let's back up. Bag of cookies X costs $3, and a slice of cake Y costs $5. The class wants to raise $900. In problem number 3, they're asking us to write a linear equation that describes the problem. They want us to put it in standard form, which is AX plus BY equals C. All right, so let's go ahead and do that. And let's go ahead and get rid of this here for 1 and 2. And so now in our example, we're going to, of course, change the number. So this is our example for number 3. And we're going to say that cookies cost $4 a bag, and cake is $8 a slice. So cookies are $4 a bag, cake is $8 a slice. So just like in the problem, cookies will be our X, the number of cookies, or number of bags of cookies will be represented by X, and the number of slices of cake will be represented by Y. So we're going to put this in the form of AX plus BY equals C, our standard form for a linear equation. And it turns out this is actually really quick to do. So since cookies, the bags of cookies is going to be our X, the total cost for the cookies would be 4X. $4 per bag times the number of bags that we sell. Similarly, for the cake, it's $8 per slice of cake times the number of slices that we sell. So we have 8Y is the total amount of money that we earn from, from the cake. All right, so that's the money we make from the selling bags of cookies, $4 per bag. So again, we hear that word per, that's telling us we know the variables there. And then $8 per slice of cake, so 8 times Y. So what's that going to be equal to? Well, remember, they said we want to raise a certain amount of money, and our goal in our example is going to be $1,000. So the money we make from selling the cookies plus the money we make from selling the slices of cake is going to equal $1,000. And so that's our equation, and that's our answer for number 3. Number 4, it says find the X and Y intercepts, then graph the linear equation. Make sure to label both axes and with appropriate titles. All right, so let's go ahead and do that. And here we go on number 4. And for number 4, we're going to need that equation up there. So let's remind us what that is. 4x plus 8y equals 1,000 for our example. All right, so we found X and Y intercepts before, so this is going to be the same process. Hopefully this will be a review. If not, once again, we'll be going over the process for you. So we'll start with the X-intercept. And remember, for the X-intercept, every point on the X-axis here, the Y-coordinate is 0. So to find the X-intercept, you substitute 0 for Y. So let's go ahead and do that. We have 4X. We're going to substitute 0 in for Y, and that's equal to 1,000. So we've got some simplifying we can do. 8 times 0 is 0. So we have 4x plus 0 is 1,000. Now, we have 4x plus 0. Yes, these are not like terms. This is a variable. This is a constant 0. But adding or subtracting 0 to something doesn't change it. So 4x plus 0 is just 4x, and we have 4x equals 1,000. Our last step, x is being multiplied by 4, so we divide by 4 to each side. 1,000 divided by 4 is 250. So our x-intercept is going to be 250. And to write that as an ordered pair, we would write that as 250 and 0. All right, so that's finding the x-intercept, and we're going to go ahead and write that up here to remind us, because now we're going to erase all of that and find the y-intercept. So let's go ahead and do that. So to find the y-intercept, we're going to substitute 0 in for x. Now, why are we doing that? Because any point on the y-axis, the x-coordinate is 0. And so let's go ahead and do that. We've got 4 times 0. And you're going to see that when it's in standard form, the process for both the x and the y-intercept is very similar. So 4 times 0 is 0. 0 plus 8y is just 8y. And then our final step already, y is being multiplied by 8. So we're going to divide 8 to both sides. The 8's cancel. And 1,000 divided by 8 gives us 125. And so our y-intercept is 125. Now, writing that as an ordered pair, we substituted 0 in for x. Our y-intercept was 125. So the coordinates of our y-intercept, 0 and 125. All right, so now that's finding the x and y-intercept. So still on number 4, now we need to graph that. So let's come over here to the graph and see if we can still leave all of that in the display there. So let's go ahead and label this. We're going to label this the same way that they did in the packet. So this will be 50, this will be 100, this will be 150, this will be 200, this will be 250. It looks like they go up to 300, so we'll go one more to 300. Same thing on the y-axis. This will be 50, this will be 100, this will be 150, this will be 200, 250, and then 300. And I believe that's as far as they go. All right, so now it also said to label the x and the y-axis. So let's go ahead and do that. Let's maybe just move this over a bit. So remember, how do we label this? Well, remember at the beginning we were told, if you look back at the very top of the page, that cookies was our x represented by x. The number of bags of cookies is represented by x. So this is the x-axis here. So this would be cookies, or bags of cookies. The y-axis, y represented the number of slices of cake that we sell. So we're going to represent the y-axis with slices of cake. All right, so now we're going to plot our x and our y-intercept. So starting with our x-intercept, the x-intercept right here on the x-axis, here's 250. So we're going to put a point here. Now for our y-intercept was 125. Here's 100, here's 150. 125 is right in between those. So we're going to put a point right there for our y-intercept. So there's our x-intercept at 250 and 0. Maybe you want to label that. And our y-intercept at 0 and 125. Notice to plot those 0, 125, we don't go left or right. We just go up to 125. And then notice for 250 and 0, we just go right to 250 and just stay there because the y-coordinate is 0. So now we're going to take our ruler out and just connect the dots and not extend the line beyond those. And I'll explain why in just a second. So we connect the dots. And the reason we're not going to extend it, normally when we graph a linear equation, we're going to connect the points and then extend it and put arrows on the end. However, not in this case. And the reason for that is if we go to the left of the y-axis, now we're into negative numbers for bags of cookies. Or if we go below the x-axis, we're into negative numbers for slices of cake. And so since negative numbers have no meaning here when we're talking about bags of cookies or slices of cake, that's why we're just going to limit to everything in this, what we call the first quadrant here. All right, so that is it for number 4. That is the graph. And now number 5, let's go ahead and read number 5. It says, use the graph to determine how many bags of cookies you must sell if the class sells 120 slices of cake. Confirm your answer by substituting 120 for y in your answer for number 3, which was the equation of our line, and solve for x. All right. So sounds like a lot there, but let's take a look here. So the question was if they sell 120 slices of cake. So in our problem, we're going to ask, let's go ahead, this will be an example for number 5. So let's put that here. So the question, what we're going to be answering is if we sold 50, we're going to use 50 slices of cake. So that's, we're given that we sold that. How many bags of cookies must we sell to meet our goal? Now, remember, this line represents the 4x plus 8y equals 1,000. That's our equation. Any point on this line, any combination of bags of cookies and slices of cake, any point on this line will meet our goal, because every point on this line is a solution to that equation, which is what we graphed here. So let's take a look. If we sold 50 slices of cake, so here's 50. Now what we're going to do, and I'm going to do this in a different color so it doesn't get confused for the graph. If we sold 50 slices of cake, how many bags of cookies must we sell? So what we're going to do is we're going to extend that 50 line all the way over to the graph, and then we're going to come down to the x-axis, and it's a little bit, we're not sure, it's about 150, but we're not sure. And so that's why they're asking us to verify it with the equation. Looks like it could be a little bit less, because even if we're off a little bit on our line, that could throw our answer off. But we're going to say our best guess here, maybe 150. If we sell 50 slices of cake, we come over to the line, where we intersect the line, we go down to the x-axis, and it looks like that's 150 bags of cookies, but let's verify that. And the way we're going to do that is very similar to the way we found the x and the y intercepts. So we have 4x plus 8y is 1,000. We sold 50 slices of cake. Remember, slices of cake, if you look back at the very top, that was slices of cake was our y, was represented by y. So we're going to substitute 50 in for y. This is 1,000 there, careful. And so we're going to simplify here. 8 times 50 is 400. Now the difference from this and from when we found the intercepts is that this is not 0 here. So we need to solve this by, we're going to subtract 400 to both sides. So we need to get rid of the 400 and then the 4. The 400s cancel. We bring down the 4x. 1,000 minus 400 is 600. The last step, x is being multiplied by 4, so we divide by 4. The 4's cancel. And can we see that okay? Oh, yeah, barely. 600 divided by 4 is 150. So again, what does x represent? X represents bags of cookies. And so if we sold 50 slices of cake, it's confirmed we would need to sell 150 bags of cookies. And that's our answer to number 5, which we thought it might be, but also if we really look closely, might say, well, it looks like it intersects at a little before 150. Might think, well, maybe it's 145 or 140. But again, we confirmed it with our equation here, which is going to be exact. Whereas graphing is great because you can visualize and see it. However, if that line's off even by a little bit, that could throw your answer off. All right, so that is it for the examples for lesson 7.1. Again, pause, rewind the video. We'll just step out of the way in case you need to see the whole pause and see the whole thing there. So again, pause, rewind is needed, and I'm sure you're going to do great with the work as always. And do your best with it, and we'll see you in the next video. Until then, take care and God bless.